We are at Moss Beach on the coast of California, a little bit south of San Francisco. What you can see behind me is the Pacific Ocean and cliffs that contain sediments that settled to the bottom on the seafloor when sea level was a little higher here relative to the coastline. Often we talk about seas covering other parts of the continent, for example, the Appalachian Basin over New York State. It's kind of abstract to imagine, but here you can see it kind of directly. You can see the ocean right next to the very cliffs that have sediments from the bottom of the sea that formed just a few million years ago. And when I say just a few, it's not very much compared to many of the continental seas that covered North America, for example, the Appalachian Basin, hundreds of millions of years ago. Behind me you can see the cliffs next to the Pacific Ocean. We're at Moss Beach, south of San Francisco in California. Sometimes we talk about ancient seas covering parts of our landscape, for example, over the Appalachian Basin in New York State, Pennsylvania. And it may seem really abstract to imagine a large water body covering the area and leaving behind sediments, but here in the cliffs you can see sediments left behind on the seafloor when the Pacific Ocean was just a little higher relative to the coastline a few million years ago. Okay. Wherever we go, we see many parts of the Earth system interacting with each other. But coastlines like this one are especially classic. Here we see the ocean, the wind from the atmosphere, we see the lithosphere, in other words, the sand and the rock, and the biosphere, the plants and the birds and the creatures living in the ocean, all interacting on a daily basis. We can walk along the coastline and see each one of these systems affecting the other ones. In this particular case, you can see the tides coming in and out over the course of the day. When the tides go out at this locality, Moss Beach, there are tide pools filled with various kinds of marine creatures that live in those pools and are obvious to somebody walking along the beach. Later on, they're covered by the high tide and they disappear from view. You can see the water moving up and down the beach, moving the sand and the rocks up and down the beach. Eventually, some of the finer grains will move offshore and settle there. And some of the sand and mud that's fed to this beach comes from streams that flow down from the local landscape onto the beach. And those grains are either washed out to the deep sea, or some of them are moved along the shore where they become part of the cobbles and the sand of the beach. Okay? You can hear me okay? All right. I'm standing in a stream that's flowing into Moss Beach on the coast of California. It's been usually dry and this stream would be quite small, but it's really flowing right now. And you can see the influence of the stream carrying the sediment, fine grains, making the water muddy, leading out into the ocean here. Some of those fine grains will end up settling in the deep ocean miles from shore. Some of the bigger ones will be dropped right here by the shore once the water doesn't have enough energy to carry them any further. This is sort of the lifeblood of sediment. This is where sediment comes from the land surface, enters the ocean, and leaves behind the sedimentary record by which we know about the history of the Earth. I'm standing on a rock in a stream that's flowing into Moss Beach on the coast of California, south of San Francisco. You'll notice that this stream is filled with flowing water with slightly brown. It's got mud in it being carried from shore. Usually the stream doesn't flow this fast, but it's been especially rainy in California recently. And a lot of the geologic record from sediments that accumulate, okay, I'm going to stop and start again. I'm standing in the stream that's moving in. Start again. I'm standing in a stream that flows into Moss Beach on the coast of California. Often this stream would be quite small, but recently we've had a lot of rain and it's really flowing fiercely with lots of sediment. You may be able to see the slightly brown color of the water. That, of course, is mud being moved from the land, weathered off of rocks there, and being eroded off into the ocean, where some of it will be carried into the deep ocean where it'll settle. Some of the coarser grains will probably be deposited right here on the beach once the water energy isn't strong enough to carry them any further. Much of what we know about the history of the Earth is a result of processes like these. Sediment moving from the land into the ocean, being deposited, and carrying with it the history of a particular place. I'm standing in a stream that's flowing into Moss Beach on the coast of California. This stream would normally be quite small, but it's rained here a lot recently, and the water is really flowing fiercely from the land into the Pacific Ocean. You may be able to see that this stream is kind of brown from the mud that's being carried from the land where small particles have been weathered from the rocks, and it's being carried out into the ocean. Some of it might be deposited miles from here, but some of the bigger grains will be deposited right close to shore after the water energy is low enough that it can't carry these larger grains anymore. The rock record is in part a result of processes like this, moving sediment from the shore out into the ocean where it gets deposited, forming layer after layer, preserving with it much of what we know about the history of the Earth.
So this is doing a 3D scan. We're going to do a scan of this cobble right here. I put it up on top of what's not exactly a boulder, because if you kick it, it'll fall apart. But that allows me to get around it. And I'm going to use the Turnio app, which is TRNIO. And there are other apps that will do this. This one's free, and I've had pretty good success with it. I'll also note that I'm wearing these gloves that allow me to operate a phone or a tablet with the gray parts of the glove. To start the Turnio app, you hit the camera icon, and then it tells you tap the screen when you're ready. You point it so that it's got a bullseye on the screen, and you tap the screen to start taking the image, and you keep whatever it is you want to do the scan of in the center of that, and it flashes lightly once you've taken the first image. And then you'll walk around it a few times, and again keeping the object you're scanning in the center, trying not to fall down as you walk through the loose sand. And you go around it a couple of times. I'm kind of pointing down at it now. We'll go over the top. It's not ideal that I cast a shadow on it some of the time, but I think the software will take care of that. You go over the top in a few different directions like that, and then go around again from a lower angle, again keeping the target in the center of your screen, in the center of the bullseye on your screen. And I'm losing it some, but that'll be okay. Software will clean that up. And that should, I think, do a pretty good job. And then when it's done, whoop whoop, you've got a bunch of green dots kind of all around the thing, and you hit and hold the center, and it says saving images, leave Turnio open, and it won't stitch it until you're in a Wi-Fi environment. One of the downsides of this is because the work is done in the cloud, you can't test it in the field to see if you've got a good image or not. So just take a bunch. It does take up a fair amount of space. I think I've got 2 or 3 saved in my phone right now, and that's over half a gigabyte of space on the phone, so you do need to make sure you've got space on your phone. But it's pretty simple to use, practice, and it gets your results become better, and there you go.
I'm on Moss Beach in California. This is the first time I've come to this place. I came with several colleagues to document it for a virtual fieldwork experience. When you come to a new place, there's a lot to look at, and sometimes it's hard to know what's what and how to interpret the history of the area. For example, there are a bunch of boulders on the hillside over here. Might be tempting to assume that that would be part of the local geology. Well, those boulders were brought here, actually, put there to protect the cliffside. They actually are a part of the local geology in the sense that they were brought from another place in California. There are a variety of kinds of Jurassic and Cretaceous rocks that tell an interesting story, but not the story of this particular beach. Well, how would you know? You know because they don't look like they're in place. They don't look like they're still connected to the layers in a cliff or some other kind of outcrop. There's also, in this particular case, a cliff of sediments over to my right. This is part of the local geologic story, but not the part of the story that I came to investigate. These are Quaternary terrace sands. Okay. Okay. Right. There are also these layers over to my right. These are thick sand deposits from the Quaternary. They're an interesting part of the geologic story, but they're not part of the geologic story that I came to investigate. They are a later part of the story. These sands are effectively on top of the rocks that I came to look at. And these particular deposits don't have fossils in them, or very few. On the other hand, I came to look at these rocks over here, which have been tilted. They tell a story of tectonics that cause some folding and faulting in this area. And these rocks are packed with fossils. Not all of them, actually. Some of them have lots of gravel in them. Some of them have are thick deposits of fine sand with only a few fossils, and some of them are dense fossil layers. But it's this variety of layers that tells us something about the history of the environments in this particular place. So in order to understand this particular part of the record that records Earth history in the ocean just off the coast here from a few million years ago, we have to look at these particular rocks. And these rocks are in place. They are slightly tilted, so we have to sort of walk across the section in order to follow them through geologic time. So when you first come to a new site, the best thing is to walk around and see what's there and to kind of get a sense of the way it looks from a distance. So in this case, we see these rocks that seem to be tilted slightly. From a distance, it looks like there might be something different from layer to layer, but it's probably difficult to tell exactly what it is. However, if I were to walk up close to those units, then I would be able to begin to see that there's actually some really big differences from layer to layer. I can see close up that this rock is made out of a very fine sand, whereas this rock is made out of very coarse sand and fine gravel. It looks completely different when I get right up close, but from a distance they just look like they're a little bit different in texture and color. So in order to investigate the geology of a place, it's really important to take both of these perspectives. I wouldn't be able to see how these rocks are tilted and how they are relative to each other unless I were standing back first, but I wouldn't be able to see what they were made of and begin to make sense of their geologic history until I get right up close to them, maybe even with a magnifying glass, or until I've taken a couple samples and studied them closely. Okay.
Okay, so the first thing you need to do is get stable in a place that, of course, you're not killing anything. In a situation like where we are here in Half Moon Bay, you've got to be careful walking out across the rocks at low tide and not step on living things that of course we want to protect. Then get yourself set up. This is a lighter weight tripod than is probably ideal for this work, but it's nice and portable, so it's what we're using. And you do want to keep it company on a windy day. I have had this blow over on me in the past, which is not very nice, and it would be not very nice at all here in the coastal water. And the next thing you want to do is get level, and there is a bubble level on the top of the gigapan. With a tripod like this, you want to extend it probably all the way up. And of course, I spent some time figuring out exactly where to go. And it's kind of an optimization problem, because if the time of day was different, we wouldn't have issues with shooting into the sun. But we needed to get here when the tide was out so we could actually see the formation that we're trying to shoot. And there it is, off in its glory. And we're going to get a little bit of sun. I'm going to set it up to go from out that direction to the cement retaining wall over there roughly, and that'll capture a good chunk of the formation. To do that, you follow the instructions on the GigaPan. The GigaPan sort of tells you a lot about what to do. You'll turn on the camera and remember to take off the lens cap first, because this camera will remind us about that. And we'll turn it off and turn it back on again, and extend the telephoto as far as you want to go. Generally, you want to do the maximum zoom. On this camera, it's a 10 times zoom, and you set up the GigaPan using the GigaPan instructions again on the unit itself. When you power up, you've got some menus you can scroll through. One of them is setup, and it will tell you how to go about setting the GigaPan for the field of view of your camera at whatever zoom you choose to do it at. And essentially you line up you set it on the zoom you want. You then use the GigaPan controls to tilt the camera and line up the field of view with the top and the bottom of the first one, then the other, to determine the field of view of your camera. I've already done that. We're set at a 3.8 degrees field of view, and so I'm going to do a new panorama, and I click OK. It says set to full zoom, then press OK. So we've set to full view. Set upper left, and then press OK. So I use the controls on the GigaPan. Don't do it without using the controls on the GigaPan, because then you'll ruin the gear system within the unit. And we don't have to go very high here because we're at sea level. And we kind of line it up with the farthest out we want to go to the left, and hit OK. Making sure that the camera's set up the way you want it to before you dig in, of course, and that has to do with setting it to landscape mode and locking exposure, and that's going to vary with the controls on your camera. So I set it to upper left and click OK. Then it tells me upper left corner set, and now set lower right and press OK to set. So this is going to be a long skinny panorama. Skinny-ish, not real skinny, because I do want to get a lot of the foreground in here. And click OK. And now that we've set the upper left and lower right corner, it will ask me if I want to show the panorama, and I will, and it will go to the four corners one at a time, and then back to the center. So it's moving to the top left corner, and I look through the viewfinder and see if that looks reasonable, and I say, yeah, that looks reasonable, and click OK. Swings me back around to the top right corner, and if that's okay, I click OK. Moves it down to the bottom right corner, and I click OK, and it swings it back over to the lower left corner, and I take a look and say that looks okay, and then it moves it to the center, and I say that looks okay. It's just the edge of that lone rock out there, the smaller of the two big ones. It says press OK to continue. I press OK. I'm going to take 480 pictures, and I say OK, let's go. And it asks me camera on, and I say OK. And balance locked, and I say OK. Exposure locked, and I say OK. Focus locked, OK. It's set on landscape for this one. Flash is off, press OK, and it starts taking the panorama. And it counts down. We're taking column 1, row 1, picture number 1 of 480. And I make sure that it's actually taking the pictures. And It's hard to tell when you're shooting into the sun, but we are up and running, and that's the sort of the gist of it. Obviously, you have to get up and close to it and see the panorama, see the Gigapan, and keep track. It's set to a little over 3 seconds per click of the shutter, and that's probably too long, but if it's too short, then you end up with the possibility of skipped images, and when you skip images in this big rectangle mosaic, you run into all kinds of problems trying to figure out how to do some kind of repair work on that by filling in either a double of an image that's kind of similar to the missing image or something like that. That's no fun. So giving it a little bit longer exposure is the way I've worked around it anyway. And this will take about, for this big a panorama, it'll take about 20 minutes. You can do the math, 480 times 3.2 or 3.5 seconds. I forget what I set it to, but that's an adjustment you can make based on how it works with your camera. And like I said, I recommend making it longer than you think is necessary rather than shorter, because you'll have fewer problems when you go to stitch the panorama. So there's software that comes with the unit, and this unit is, I believe, the middle of the line of either 3 or 4 different Gigapan units. The smallest one just holds little point and shoots. This will hold an SLR, but not an SLR with a big zoom on it. And you can buy those, and they are in the order of a few $100s. There is an educator discount, so look for that. And the website for Gigapan is gigapan.org, where you can see the stitched Gigapans from all over the world. So now we wait. So that's part of what's happening right now. So you turn the unit on, the camera you turn on, and there are settings for the camera, but of course they're different for every camera. You want to lock your white balance, which you'll need to see your owner's manual to figure that out. You want to take off the lens cap before you turn on the camera, as a general rule of thumb. And if you're doing a distance like this, you want to set it in landscape or set the focus to infinity. That'll save you battery, and each frame will be quicker. You can set the duration between clicks on the Gigapan. That's quite easy to do in the setup menu. So you turn it on and it calibrates for a moment or two, and you've got choices of new panorama, which is what we'll actually end up doing, 360 panorama. Last panorama, you can repeat the same one you had done earlier, and options will allow you to set the time per pick right now. Oh, and the time per pick right now is 3.4 seconds per picture, and I could probably shorten that up, but it's better to have it go too long than to skip a picture, because skipping a picture is kind of a mess. And you can check battery status, which I'm glad that it said that, because I need to change the batteries, because the battery status is good, it says now. Before it was saying it was dying. You can change the battery pack in the middle of a Gigapan, so we'll go with its good saying. And this model takes 6 AA's. Other models are different, and I'm not sure what that is. And then some other things there that I don't generally deal with. We'll say okay, get out of here, and we will go to, we'll take a quick look at Gigapan setup. The current field of view is 3.8 degrees. To set that, you turn your camera on, you go out to full zoom. For the sake of time, I'm not going to do that right now. I'm not going to set it up, but it does step you through the process, having you set the camera on the bottom of the, so that the field of view lines up with the bottom of the horizon and the top of the horizon, and the difference between those two zooms determines your field of view. And if you change the zoom on your camera, zoom in, zoom out, you'll need to adjust that setting, and it automatically figures in a little bit of overlap for when it shoots the pictures. And now we will say OK, and here it's telling me to do that stuff, and I'm gonna get out of there and go to new panorama and say OK, and I've got it set to full zoom, and so OK, and set to upper left. This is going to be just a 3 or 4 or 5 maybe images high, and you use the buttons to move the camera and get to the upper left where you want it. And I'm going to say OK, and then it tells me to set to lower right and press OK. So I'm going to go down, and you kind of fiddle around to oops, and I hit the wrong button, so you start over again. So it says new panorama, I hit OK. Set to full zoom, that's already done. Set to upper left. So I go back over here. Somewhere out there. Go up a little bit above sea level. Set OK. Set to lower right. Swing around. Again, use the controls on the Gigapan to bring it down. If you force it manually, you'll stress out the gears on the unit. You don't want to do that. And I think that's okay. And it now says lower right set and show panorama. I click OK to say yes, and it'll go around to the 4 corners and show me each one. And that looks fine. So this is going along the top, and that looks fine. Go down, and that looks fine. And that looks fine, I think, except for the camera just shut off because I hadn't touched it in too long. So, you know, this is part of the excitement. This is a pro at work. But the Gigapan didn't go off, so it's still knowing where I am, and since it was just set to full zoom, I didn't have to know anything, and it goes out to the center now, and we press OK to start, and this will be 135 pictures, and I say OK. The batteries in the Gigapan will die in the middle of this, but you can just swap out the battery pack, and you're good to go. And it's asking me questions about the camera settings, and I'm saying OK to all that, and now it'll start taking the panorama. And while it's doing that, I make sure that it's actually hitting the shutter button each time. And it's worth noting that when you set up, and now it says please replace battery. So I've got my batteries in my pocket here. That I was going to say, and I'll talk about this while I'm swapping out the batteries. You want to leave about a millimeter gap between the robot arm that pushes the shutter button and the shutter button, so it gives enough leverage. I did not know that when we initially did these things, and found out that it would very often, and on a number of different cameras, it would skip pictures if the robot button here was set up so it was right on top of the shutter. So you do want to leave that like between 1 millimeter and 2 millimeters gap there. Seems to work well in our experience. And as you can see, you can swap the battery pack out and not have a problem. More expensive batteries are better. These sort of bargain basement alkalines didn't even last a full gigapan. So, and it was a big gigapan that killed it off, but it didn't last a full gigapan. So different models have different battery packs. So this one has 6 AA's. You put them in correctly. And we are good to go. So stick that back in. And power it back up. And make sure the camera's still on. Well, I should have turned it off in the interim. And I'm just going to start over for, I think it had only taken one picture. And just, it will, one of the options is last panorama, so I'll just go with the last panorama. And I'm going to skip it and have faith that we're in good shape there. And there we go. I do, as I said, check and make sure that it's actually taking pictures with each movement, and it seems to be on the first few anyway. And this is going to be 135 pictures at 3-point-something seconds per picture, so 3 times 135, about 500 seconds, whatever that works out to be. Not too long. I also usually take a picture of the gigapan taking the gigapan so that it's easy to do the georeferencing, put it in the right place. So I do that with my smartphone so that it is geotagged, and just snap a picture while it's snapping pictures. And there we go. And that makes it easier to put it in the right place. When you stitch the gigapan on your computer, it puts it into a grid, and you see this mosaic, this rectangular mosaic of the pictures. This will be, I forget what exactly the dimensions are. I think 5 by something to give you 135. It's helpful to remember that when you go into arrange the gigapan. It does not automatically recognize, the software does not automatically recognize how many rows there are, and you'll sometimes find that deleting pictures from the first or last row is necessary because it somehow ends up with an extra picture or minus a picture in the first or last row. So doing that helps, and then it'll stitch in, depending on how big the gigapan is, somewhere between a few minutes and an hour or two. It used to take much longer. The first models took the first software took much longer. Now most gigapans can be stitched in a couple of hours anyway. Once it's stitched, you can use the gigapan software to upload it to gigapan.org, and once it's uploaded, you can georeference it, and with a little bit of fiddling around on the gigapan site, you do need an account to do that, to upload, that is. And once you're in your user view of a particular gigapan, you can put it, georeference it so that when you zoom into it in Google Maps or Google Earth, you can actually go from the global view down to street view and into the panorama, and it'll, if you are careful, you are the one who lines it up. It doesn't automatically line up or anything like that, but with a little bit of practice, you'll get pretty good at setting it in Google Earth so that you can see the Gigapan set in the right place, and it will show up on Google Maps and Google Earth for whoever wants to use it. Downloadable as a KMZ file.